So in this lesson, we're going to talk about how to use a solubility curve to look at the solubility variations among temperatures. So what we're looking at here is a solubility curve, and it shows the variation in the maximum solubility at different temperatures for individual substances. Every substance has its own solubility limits. Let's look at NaNO3, which is represented in the red line up here at the top. And what we see is that at 0 degrees Celsius, in 100 grams of water, about 72 grams of NaNO3 will dissolve in water. That means if I put less than 72 grams, it will all dissolve. If I put 72 grams, it will all dissolve. But if I put 73 grams, only 72 grams of it will dissolve, and I'd have a little bit left as a solid or a precipitate in the bottom of the container. So what these lines represent are the maximum solubility of each of these substances at a specific temperature. Now notice here on the x-axis we have our temperature, so from 0 to 100, and then we also have our grams of our solute. In this case we're only looking at aqueous solutions, so we're only going to be looking at water. And notice this is for 100 grams of water. If we're looking at questions where we have a different amount of water, we'd have to do the appropriate scaling to determine the maximum solubility. And we'll look at some examples of how we use this. So let's look what happens when we go on to, say, 20 degrees, still looking at our NaNO3, our sodium nitrate. So at 20 degrees, the maximum solubility goes up to about 88 grams of NaNO3 per 100 grams of water. So now let's look at a different substance. What mass of KCl will dissolve in 100 grams of water at 10 degrees Celsius? So the first thing I need to do is look for the line representing KCl, which is right here through the graph. Okay. Then I go to 10 degrees, and I don't have to worry about any scaling because I'm dealing with 100 grams of water, and this is asking about 100 grams of water. So I say 10 degrees, go up to the KCl line, and I see that it's approximately 30 grams of KCl will dissolve in 100 grams of water at 10 degrees Celsius. So now let's look at a different problem. How much potassium dichromate can dissolve in 25 grams of water at 90 degrees Celsius? So we have three pieces of information. We have the compound, we have the amount of the solvent, in this case the water, and we have the temperature. And so what we need to look at is first find our curve for the appropriate substance, and that's this one right here. Then we have to look at the temperature. So we have our 90 degrees for that substance, and it crosses about there. Now we look at this and we say, okay, this is the amount. It's about 70 grams of the compound, but that's in 100 grams of water. And we don't have 100 grams of water, we have 25 grams of water. And so to find the amount, we say, well, 100 divided by 25 is 4. So 25 grams. And so we also need to divide 70 by 4. So we get about 17 and a half, so we'll round that to 18 grams of our K2 Cr2O7 will dissolve in 25 grams of water. So we have to be careful about this particular amount because the amounts given in the graph are almost always 100 grams of water, but you also need to look at the y-axis to determine that. So this problem is a little bit different using our curve, and we say a solution is prepared with 20 grams of a salt, so one of these compounds, we don't know which one, in 100 grams of water, and I see that's the same, so I'm not going to have to do any scaling, at 70 degrees Celsius. So 20 grams of our compound, 70 degrees Celsius, and all of it dissolves. Okay, so it's completely soluble. Okay. The solution is then cooled to 45 degrees Celsius, and some of the solid precipitates out. Now, when we went from 70 degrees to 45 degrees Celsius, did the amount of the substance in the solution, dissolved and undissolved, is the total amount still the same? Yes, it is, because notice it doesn't say anything about removing or adding. It says some precipitates out, but there's still 20 grams of compound in that container. So the only thing we're looking at is looking at this temperature change, 70 degrees to 45. That's the only change we have to worry about. Now, at these conditions, it says it's not all dissolved because some of it precipitates out, which means some of it comes out as a solid. So now I'm going to find these 2 points on the curve. First, I'm going to look at 20 grams and 70 degrees Celsius. Mark that there. That's our initial conditions where everything was dissolved. And then I'm going to look at 20 grams and 45 degrees Celsius, which is approximately there, and know that some of it is not dissolved. So at the first point here with the red X, I look at my different compounds. And if I look at KClO3, for example, it tells me the maximum solubility of KClO3 at 70 degrees Celsius is 30 grams. Therefore, anything less than 30 grams will completely dissolve. So if I had 20 grams of KClO3, it would all dissolve. 20 grams of NaCl would all dissolve. 20 grams of any of these other compounds, and they are all going to dissolve because it is less than their maximum solubility at that temperature. So the only thing that will not completely dissolve when I add 20 grams is the cerium sulfate. Okay? So the Ce2SO4 So if I put 20 grams of this compound, the Ce2SO4 it is above its maximum solubility, which at 70 degrees is about 3 or 4 grams. So it would not all dissolve. So that means it can't be this compound, but it could be any of the other compounds that I see because all of them have a maximum solubility greater than 20 grams at 70 degrees Celsius. So this first bit of information only eliminates one option for this particular problem. Now I have to look at the change, and I go from 20 grams of my compound to 45 degrees Celsius, so we've represented that with the blue X. And now I want to look at it and I see that not all of it dissolves. So this is the key step here, because if I look at any compound that has a solubility above the 20 grams, so let's look at potassium dichromate here, what I see is that its maximum solubility is about 25 grams at 45 degrees Celsius. So if I only had 20 grams of that compound, it would completely dissolve, which does not fit the description of my solution given in the problem. Same thing with NaCl. We have a solubility of about 36, 37 grams. So if I only put 20 in, it would all dissolve at that temperature. So that allows me to eliminate anything that has a solubility greater than the 20 grams per 100 grams of water, which means the only thing I have left is my KClO3. Because I limited the cerium sulfate because it didn't fit the description of the first solution, I'm eliminating anything else because it doesn't fit the description on the second solution. So what I'm left with is KClO3.